Hi, we're Team Metal Squad. My name is Igor DePaula.
My name is Alexis Weaver.
My name's Tarana Chaudhary.
I'm Don Pham.
Our objective was to recreate the game system so we would emulate the gaming experience of playing Street Fighter 2. We implemented two characters, Ryu and Ken. Both of them had different moves that included walking, idle state, crouching, jumping, two different kinds of attacks, a punch, kick, and a special attack each. We also implemented a health bar, a knockout screen, as well as a start screen with the Street Fighter logo in front.
Let's have a look at the game.
In order to actually load the game, open up the Digital Adept tool and in the Memory tab, select the RAM option. Then under Write File to Memory, first load in the Ken reduced odd binary file at address 0 in decimal. Once Ken is written, you can write Ryu after selecting the Ryu reduced odd binary file, write Ryu to the start address 950,000 in decimal. Once both binary files have been written to memory, you can configure FPGA by selecting the binary file and then programming. This is the initial screen of the game. As you can see, the Street Fighter logo is centered in the middle of the screen and both characters are frozen. Upon hitting the Start Push button, the game will unfreeze and the characters will enter their idle state. For attack moves like kick and punch, the health bar will decrement upon collision detection. And Ryu's or the opposing character will respond accordingly. When a character wins, the following screen will appear. In this game, Ken has lost and so he is in the knockout state, and because Ryu has won, he is in the victory state, and the KO logo will flash repeatedly in the center of the screen until the start button is pressed.
This main module acts as a container for all submodules, including VGA display.v and cellular RAM controller.v. The inputs include all the JAMA signals, which are processed with the standard debouncer, the VGA inputs and outputs, and the cellular DRAM control signals. This module allows the use of the onboard DRAM. It connects with the DRAM using the clock and a list of pre-specified signals. We have implemented this controller to use asynchronous mode to request data using the address provided by the VGA display.v module. This module outputs all control signals to the DRAM. This module contains all logic for the game. It takes as inputs all the debound signals from the JAMA interface, the VGA interface signals, and the pixel value provided by the DRAM controller output using the address requested by this module. It has registers for storing the vertical and horizontal location of each character, the health, the current move, and the state of that move, and the state of the game. This game screen starts in the pause state. In this state, the Street Fighter logo appears in the middle of the screen with both characters frozen at each side. Upon pressing the start push button, the characters will unfreeze and enter their idle states. To reset the game, the start button can be pressed, returning all registered values to their initial conditions. The game enters the knockout state when either character's health bar reaches 0. The flashing KO symbol appears in the middle of the screen with the appropriate character in the knockout state and victory state. In order to restart the game, the start button must be pressed. All character moves are detected using an always block with a sensitivity list including all inputs from the JAMA interface. The current move register is updated according to the input. After the character cycles through the corresponding frames for each move, it returns to its idle state. except for the victory and knockout moves, which continuously loop until the start button is pressed. In the hit response state, the logic checks the current move and both the vertical and horizontal location of the other character in order to detect the collision. Using an 8 Hz clock in an always block, we cycle through all the frames for each character move by updating the corresponding move register. For the jumping and walking moves, the vertical and horizontal location registers are updated respectively. Note, a faster game can be achieved by simply using a faster clock. It does not have to be particularly 8 Hz. The pixel address location of each character is calculated depending on the current move and the state of that move. The frames are defined using the corresponding sprite sheets that have been loaded onto the DRAM and vary depending on the sprite sheets used. The pixel address is calculated depending on the horizontal and vertical coordinates of the VGA. In order to transpose the second character, Ryu in our case, so the characters are facing each other, the width of the character is calculated and then subtracted from the original pixel location. The display region is also calculated using the current location, state, and move of the character. Depending on the region of display and of each character, the corresponding pixel address is selected from Player 1 and Player 2. Note that since the DRAM has a 16-bit return value, while we only have 8 bits for each pixel, 2 pixels are requested at every clock cycle by dividing the pixel address by 2. Each pixel that is extracted is displayed sequentially. These registers start at 310 pixels horizontally and decrement at every character hit by 10 pixels, unless it's a special move which decrements by 30 pixels. At reset, the health bars return to 310 pixels. The RGB assignment depends on 3 sources. The first is between the Player 1 and Player 2 regions. If the VGA is within that region, it outputs the corresponding values from DRAM. Note that if the background color is detected, then it is set to black. If the VGA is in the health bar region, the health bars are drawn. Lastly, if the VGA is in the KO or Street Fighter logo region, then the proper logo is drawn, depending on the state of the game. These 2 illustrations come from the block RAM.
To load the DRAM and program into the IPGA, the reduced sprite sheet for each character is loaded onto the DRAM using the digital adapt tool. The .png file and .gif file are converted to binary file using a MATLAB program and also converted from 16-bit to 8-bit. Each sprite sheet must be loaded in the exact location specified by the VGA display.b module. And the same MATLAB program is used to create a .coe file from the PNG file of the KO and Street Fighter image to make a block RAM module using the IP core generator inside it.